all mass spectrometers is a combined mass analyzer and detector. The choice of detector depends on design of instrument and type of experiment it was designed to perform. Detector generates a signal from incident ions by either generating secondary electrons, which are further amplified, or by inducing a current generated by a moving charge. There are three types of detectors in MS. The first one, electrons multiplier. Second, Faraday cup. And the third one, photomultiplier, or also known as scintillation counter. Electron multiplier is the most common detector in MS for ions, especially when positive and negative ions need to be detected on the same instrument. It consists of a series of electrodes, which is known as diodes, very sensitive and has fast response. Faraday cup is a metal or carbon cup served to capture ions and store charge. So the cup shape decreases loss of electrons. It is least expensive detector for ions and has long response time. So the Faraday cup consists of a metallic cup that is connected to the earth through a resistor, and the incoming ions strike the cup and get neutralized. So this results in an electric current through the resistor that is proportional to the ion abundance. Photomultiplier, or also known as scintillation counter, ion initially strike a diodes. Okay, you can see a diode here in the diagram, which results in electrons emissions. Okay, so these electrons strike a phosphorus screen, which releases a burst of photon. Okay, photon then pass into multiplier where the amplifications occur and the electric signal form. In these slides, it is showing three setup. The first one is MS, where it has one MS. Okay, one MS. I'm circulating here, and then GCMS. It could be LCMS and one chromatography, GC or LC, and then one MS. What is MSMS? Tandem mass spectrometry. So we can see MS setting up. You can see that there's a MS1 and MS2. So this is known as tandem mass spectrometry, or MSMS. Okay, why tandem mass spectrometry, MSMS? So in general, ESIMS give informations on the mass of a molecule, but none on structures. So if you look at your MS compound reports for practical, some of the compound are undetermined, or I will ask you to put just not found, cannot find in the Google, because they are not even in the database, and then there's no structures. All right, so we can actually improve the results by doing MSMS with additional charges, definitely. So in tandem MS, which is MSMS, pseudo molecular ions are selected in MS1. You can see that the first M over Z separations here. So whatever that you receive in the compound reports only go through one single one MS, and then fragmented by collisions with gas. So in MSMS, then the fragments ion will be ionized or analyzed in MS2. And another times of the M over Z ratio separations, then only will be detected. All right. Okay, I have two representations of graph here, MS1 and MS2. Ion selected by MS1 is parent ion, can be a molecular ion resulting from primary fragmentations. Dissociations occur in fragmentations regions. Daughter ions are analyzed in a second spectrometer, which is known as MS2. In fact, MS1 can be viewed as an ion source for MS2. The formations of Daughter's ion are as such equations: Mp plus to Md plus plus Mn. The Mp plus here is referred to the parent ion. Molecular ion is ion which has mass equivalence to the molecular weight of the compound introduced into ion source. Okay, parent ion needs not to be molecular ion, but both molecular ions and fragment ion can be selected as parent ion in MSMS. Tandem MS, also known as MSMS or MSNs. MSMS experiments can be described as mass selections of parent ion in the first stage of analysis within instruments. Analysis of daughter ions often performed in a collisions-induced dissociations process in the second stage of analysis. This is an illustration of triple quadruple MSMS. So you will observe that there's HPLC here, okay, as a separations units coupled to 3 triple, Q1, Q2, and Q3, then only a detector. The benefits of LC or GC tandem MS are: eliminates the needs for derivatizations, can separate and identify similar compound, superior sensitivity and selectivity of analytes. When operating in multi-reactions monitoring mode, we can quantify low level of compound in biological matrix selectively in a wide dynamic range. In conclusions, MS is useful for chemists as well as researchers from neighboring disciplines such as physics, medicine, or biology as a powerful analytical tool. Environment-free conditions of highly diluted gas phase allow more direct study of a simplified system. The tandem MSMS is a powerful technology, has opened a venue for newer and broader applications.